Hi all, in this video we're going to discuss the F-test, how to calculate it and when it should be applied. First, let's go over what the F-test is. The F-test is any test that uses the F-distribution. The F-statistic can be used to conduct regression analysis and other types of tests. The test we're interested in is the F-test to compare whether two variances are equal, and more specifically, whether in a multivariate regression, the independent variables are statistically significantly associated with the dependent variable. So a t-test is another type of statistical test that should not be confused with the f-test. When applied to a linear multivariate regression of the following equation, the t-tests whether a single beta value, or coefficient in this case, differs from zero. So for example, we could have a t-test that tests whether beta 1 is statistically different from zero, or whether beta 2 is statistically different from beta 0. But the t-test is just going to look at whether an individual variable, that is one variable, is different from zero. The null hypothesis of the t-test is that beta 1 equals 0. So basically that the univariate variable has a mean that's equal to 0. Um, so the alternative hypothesis is that beta 1 is not equal to 0 for a t-test. And then the null hypothesis for an f-test is whether beta 1 equals beta 2 equals 0. And the alternative hypothesis for the f-test would be whether at least one of these coefficients in the multivariate regression does not equal 0, or statistically different from 0. So the two possible results to an f-test are the following. First, that all regression coefficients are statistically equal to each other and equal to 0. This is the null hypothesis. Or secondly, that any one of the regression coefficients are statistically significant and different from 0. This is the alternative hypothesis. The assumption of the f-test are as follows. One, that the population is normally distributed. Second, samples have been drawn randomly. Third, observations are independent. Fourth, the null hypothesis may be one-sided or two-sided. The f-statistic is calculated by following the formula. Sum of square residuals from the restricted regression minus sum of square residuals from the unrestricted regression, divided by the number of restrictions, divided by the sum of square residuals from the unrestricted regression, divided by the number of observations, minus the number of restrictions, minus 1. Additionally, the f-statistic follows the f-distribution, and a larger f-statistic means we are more likely to reject the null hypothesis. The key difference between the t-test and f-test are as follows. A t-test is a univariate hypothesis test that is applied when the standard deviation is not known and the sample size is small. On the other hand, the f-test is a statistical test which determines the equality of the variance of the two normal data sets. The t-test is based on T-statistic, follows students' t-distribution under the null hypothesis. Conversely, the basis of the f-test is f-statistic, follows the f-distribution under the null hypothesis. The t-test is used to compare the means of two populations. By comparison, the f-test is used to compare two population variances. The takeaway from the t-test is whether or not the means of two data sets are greatly different from each other. The takeaway from the f-test is whether or not when there's a multilinear regression analysis, it examines the overall validity of the model and determines whether any of the independent variables have a statistically significant linear relationship with the dependent variable. Finally, let's look at how the f-test was applied in Erdemer et al. 2003. In Erdemer et al. 2003, Table 3, the f-test results are recorded in parentheses below the various variables. F-test significance of 0.015 for the intercept, for example, means we're more likely to reject the null hypothesis of beta equals 0, so at least one of the coefficients is statistically significant and different from 0. Thank you. I hope this video was helpful, and I look forward to seeing you in the next video.